Okay, in this video we're going to look at the basics of carbon-13 NMR. We look at carbon-13 NMR rather than carbon-12 because carbon-13 has an odd number of nucleons, so they get this spin effect which otherwise we don't get with carbon-12. So carbon-12 doesn't show up on an NMR, but carbon-13 does. But you might say, well, most carbon is carbon-12, but 1% of it roughly is carbon-13. And even in a small sample, every carbon in a molecule will be represented by carbon-13 in at least one or a few molecules, so it will show up. Okay, so if you have a look at an actual molecule and how we spot the environments. Here we've got ethane. Ethane's got 2 carbons, but it only has 1 carbon environment. If you look, there's a line of symmetry down this molecule. So if I turn this molecule around, this carbon would be exactly the same as this carbon. You couldn't be able to tell that I've turned it around. So they're in the same environment. So this molecule of ethane only has 1 carbon-13 peak on the NMR spectrum because they're in the same environment. So just 1 peak because of 1 carbon environment, even though there's 2 carbons. Compare that to propane. Propane has 3 carbons. The 2 at the end are in the same environment as each other, but this one is in a separate environment. So there's 3 carbons, but 2 carbon-13 environments, or 2 carbon environments. This was 1 environment, because if I turn the molecule around, upside down, you wouldn't be able to tell I've turned it around. They're in the same environment, they experience the same thing, they're bonded to the same things. And then the carbon in the middle is in another environment again. So there's 2 environments here, rather than 3 or 1. So each time you're looking for the symmetry within the molecule. If I look at this one, okay, here, each one of these CH3s is in the same environment. Okay? If I spin it round, you won't be able to tell that it's changed. Each one of those, there's 4 of them, 4 CH3s, and they're all in the same environment. So that only counts as 1 carbon environment, and then this is the other one. You don't have to have hydrogen there to have a carbon environment. So we've got 1, 2 carbon environments, even though there's a total of 5 carbons. So this would only have 2 peaks on a carbon-13 NMR. If we look at aromatic compounds, in benzene, all these carbons here are equivalent. So if I span the benzene round, each carbon would be equivalent to the previous one. You wouldn't be able to tell that I turned it around. Okay, so this is 1 carbon environment. In this one, methyl benzene, that's a separate carbon environment. And now that we've introduced a side group, that is another carbon environment because it's different to the others because it's the only one that's attached. And if you look, these 2 are closer to the CH3 than the others, and then those 2 are a little bit further away, and that one is directly opposite, so it's the furthest away. So we've got 1, 2, 3, 4, 5 carbon environments there. Okay, so this benzene by itself will just have 1 peak on a carbon NMR. Methyl benzene would have 1, 2, 3, 4, 5 peaks.